Hey everyone, Mr. Hawk here. We're going to go ahead and take a shot at trying to record this video here. So let's go ahead and get started. Today's topic, we're looking at factoring and completing the square. Remember, this is for algebra review for calculus. So one of the essential things you're going to need to be able to do in calculus is factor. And you also need to be able to complete the square so that you can rewrite quadratics in a more favorable form. Okay, so let's go ahead and make the key to these notes. All right, when factoring, here's some things that you always want to consider. Always, let me highlight this. Always consider factoring out a greatest common factor first. If you look at all your terms and you notice that they have a greatest common factor, that should be the first thing that you try to factor out. That could be it could be a variable, it could be a number, but always look for a greatest common factor first. If your polynomial has two terms, look for a difference of squares. Now, it might have been a little bit since you've seen what a difference of squares looks like. Let me go ahead and remind you real quick. So a difference of squares is when you have this scenario, a squared minus b squared, and it's always going to factor into a plus b times a minus b. Examples of this. Examples of difference of squares could be something like x squared minus 9. This would be x plus 3 times x minus 3. So notice that with difference of squares, you have two terms that are both being squared. We'll look at x squared and 9. X is being squared here, 3 is being squared, and the key part is that it is a difference. That's why we call it difference of squares. The sum of squares, which is a squared, let me do this in a different color, a squared plus b squared, never factors. Sum of squares never factors, difference of squares always factors. Very important to keep in mind. All right. Finally, if the polynomial has three terms, try factoring it into two terms, usually linear factors. Okay, so let's try some out here. Example 1, a through d, we're going to try to factor each one completely. So looking at example 1, first thing we want to look for is any GCF, greatest common factor. And I don't see anything. There's no term that we can factor out of all the terms that a term that they all have in common. So it's a polynomial with three terms. Now, many of y'all have probably seen this little X chart before. So what we're going to do is we're going to take the coefficient of the square term times the constant. This is, you can look at this as ax squared plus bx plus c. So what we're doing is a times c. So that's going to be 1 times negative 60. That's going to give us a negative 60 right here. And then the b term is going to go in the bottom of this little x puzzle. All right, so we have negative 60 up top. We have positive 4 on the bottom. And the goal is we want to try to find two numbers that multiply to the top, but those same two numbers need to add up to the bottom. So thinking about this, I'm seeing 10 and negative 6. 10 times negative 6 gives me negative 60. 10 plus negative 6 gives me positive 4. So what that allows us to do is that allows us to split the middle term right here. So now we're going to have x squared plus 10x minus 6x minus 60. Okay, so we're taking that 4x, we're splitting that 4x using a 10 and a negative 6. Okay, the x squared stayed the same, the negative 60 stayed the same. And now we're going to split it in half. This is called factor by grouping. You're going to look at the first two terms, and you're going to factor those. Well, if you look at x squared and 10x, they share an x in common. I'm going to factor out the x. If I factor out x from x squared plus 10x, I get x plus 10. Okay, here in the second part, between negative 6x and negative 60, I could factor out a negative 6. This gives me x plus 10. You know you did this correctly if the factors are the same. X plus 10, x plus 10. That means one of my factors is x plus 10. My remaining factor are the terms left on the outside. All right, and you might be thinking, well, that plus 10 and that negative 6, couldn't we have just stolen them from right there? The answer is yes, but only when the coefficient of x squared is a 1. You will see when we get to part C down here that we can't just simply steal these two terms right here and make them the factors. You're going to see that that doesn't work when the coefficient of x squared is anything other than a 1, okay? So you'll see that here momentarily. Now let's look at part B. All right, part B. Remember, first thing that should be passing through your mind, are there any greatest common factors that I can factor out? Well, notice both terms, we could factor out a 2, and we could also factor out an x from both terms. So, GCF, 2x, I'm going to factor out that 2x. If I factor out a 2x out of 2x squared, I'm just going to be left with an x. If I factor a 2x out of itself, I'm just going to be left with a 1. Notice when you factor something out, you can re-multiply to check. 2x times x is 2x squared, check. 2x times 1 is 2x, check. Notice also that once we've done that, there's nothing more we can do with the inside term. This is fully factored, so we're done. All right, part C. So, first thing we do, look for any greatest common factors. There is no number or variable that all three terms share in common, so there's no greatest common factor to factor out. Let's go straight to the x puzzle. So, number on top, 3 times negative 24, that is going to be negative 72. On the bottom of the x puzzle, 14. So we want to find two numbers that multiply to negative 72 that add up to 14. Now this one might take you a little bit longer to find, but the numbers that work are 18 and negative 4. 18 times negative 4 is going to give you negative 72. 18 plus negative 4 is going to give you that 14. So again, just like previously, in part A, we're going to split this middle term using these two right here. So we're going to have 3x squared plus, now instead of 14x, we're going to have 18x minus 4x minus 24. All right, now factor by grouping, split it in the middle, factor just the two terms on the left. Well, if we look at these two terms on the left, they share an x in common. So if I factor out an x, I'm going to get 3x plus 18. Actually, hold on. They share 3 in common as well. Right, because 3 can go into 18 6 times. So we factor out a 3x, we're going to get x plus 6x, right? 3x times x, 3x squared, 3x times 6x, really 3x times 6, not x. Yeah, 3x times 6, 18x. There we go. Had a little brain slip there, but everything works out now. All right, so yeah, 3x squared plus 18x. All right, over here on the right side, negative 4x minus 24, we can factor out a negative 4. By the way, when you're looking at the second piece, if the first term of the second half that you're factoring is negative, you always want to factor out a negative. So we're going to factor out a negative, and they both have a 4 in common that we can factor out, negative 4. Okay, if we factor out a negative 4 from negative 4x, we just get the x. If we factor out a negative 4 from negative 24, we get plus 6. Notice again, the thing we're looking for says parentheses, the terms inside the parentheses to be the same. That's how we know we did it correctly. So that's going to be one of our factors, x plus 6. Our other factor, 3x minus 4. All right, part D, last one for the factoring examples here. So we have 4x squared minus 100. Again, first thing to check, is there anything that we can factor out, any greatest common factor? I can see that both terms are divisible by 4. So greatest common factor is 4. Let's factor out a 4. If I factor out a 4 from 4x squared, I get x squared. If I factor out a 4 from negative 100, I get negative 25. All right. So is there anything that I can still do? Well, this x squared minus 25 is a difference of squares. Difference of squares. All right, we just talked about this right up here. When your two terms are both perfect squares, you're subtracting them. Well, this is x squared, this is 5 squared. So this is going to be, keep the 4 on the outside, x plus 5 times x minus 5. Right? So that kind of covers the basics of factoring. We've seen factoring where the leading coefficient is a 1, very easy. We've seen factoring where you just factor out a greatest common factor. We've seen a little bit more complicated factoring where the leading coefficient of x squared is not just a 1. Makes it a little bit more complicated. And then we've seen some difference of squares example. All right, next thing we want to talk about is completing the square. Now, luckily for us, we are pretty good at completing the square. We had to do a lot of completing the square this year for conics when we were doing ellipses and hyperbolas and circles and things like that. So completing the square is one of the things that I feel like we're relatively strong at. But one of the reasons you would want to use completing the square is to rewrite a quadratic in what we call vertex form. Vertex form has some unique advantages. First off, it tells you the vertex, which is something nice. And in calculus, sometimes when you rewrite your quadratics in vertex form, you can pull off some nice little calculus tricks that you'll learn about then. Okay, so let's go ahead and use completing the square, but only to rewrite these quadratics in vertex form. So starting off here, we're just going to take this part, x squared plus 10x minus 24. Let's go ahead and set it equal to 0. Remember that when we were doing completing the square, we had always kicked the constant over to the right side. So x squared plus 10x equals 24. And then we would play our little completing the square game. We would say, okay, what number can I add in right here that turns the left side into what we called a perfect square trinomial? And we did that by looking at the middle term's coefficient, that 10 right there, and we would cut 10 in half and square it. Well, if you cut 10 in half, you get 5. If you square 5, 5 times 5, you get 25, okay? But we also remember that you can't just magically add a number to one side of an equation. You have to keep the balance of the equation by also adding that 25 over here, plus 25 over here as well. So that gives us x squared plus 10x plus 25 equals 49. Remember, the whole point of doing this was to rewrite it as something squared. Okay? Well, remember how we cut that 10 in half to get a 5? That's what's going to go here. And here is just going to be x. Okay? So x squared plus 10x plus 25 is x plus 5 squared equals 49. And then the last thing we want to do is we want to get this 49 back over with the other terms. X squared plus x plus 5 squared minus 49 equals 0. And then what we're going to do finally, we're just going to set it back equal to y. So y equals x plus 5 squared minus 49. So what we just did is we took our quadratic in standard form and we rewrote it in vertex form. These are the exact same thing. These are the same quadratic, just in different forms. Standard form, vertex form. All right, let's try another one. Y equals 6x squared plus 12x minus 31. All right, so same deal. 6x squared plus 12x minus 31 equals 0. Kick the constant over to the other side. 6x squared plus 12x equals 31. All right, now on this side, what's going to make this one a little bit more complicated than this one, over here, notice we had just a 1 attached to this x squared. Here we have this 6. We don't like the 6 there. We need to factor it out. If it's anything other than a 1, we need to factor it out from this left side. So factor out 6. If I factor out 6 from this, I'm going to get x squared plus 2x. Right, equals 31. And now let's do that completing the square step in here. All right, so we're looking inside the parentheses. Look at that middle term's coefficient, that 2. Cut it in half. Half of 2 is 1. Square that. 1 squared, 1 times 1, is 1. But we need to balance it on the right side. Well, remember, this plus 1 is getting multiplied by this 6. All right, so what we have, 6 times x squared plus 2x plus 1 equals 37. All right, remember, again, the whole reason of doing this, the whole reason of completing the square, is to be able to rewrite that piece there, this piece here, as something squared. Well, again, when we cut that middle term in half, we got a 1. So this is 6 times x plus 1 squared equals 37. Take that 37, move it back to the other side. 6 times x plus 1 squared minus 37 equals 0. And then just reset it equal to y. And we have successfully used completing the square to rewrite our quadratic in vertex form. All right, that's going to be it for this video. Make sure that you try out the practice problems. The key to the practice problems should be online.